Hello everyone. We will get started then in a second here. So hopefully everyone can kind of see and hear me okay. And today we are kind of going to be working on some geometry problems for this morning session. So I know some of you guys in chat already were kind of talking about afternoon session, right? We will have an afternoon session for middle school geometry. So middle school geometry session at 1:30 to 2:15 p.m. Pacific time today. So a couple hours after this one in the afternoon here. We will be doing some kind of middle school geometry later today as well. Okay, so glad to hear people can kind of hear me okay and stuff like that. So just right as a little bit of a reminder and a little bit of kind of warning at the beginning, right? Just kind of want to quickly talk about our rules for today as well, right? So be sure we are being nice to everyone, right? You can share answers, you can't chat super fast anyway, but if you're kind of spamming the answer or things like that. You can share the answer, but please don't share it over and over and over as we're kind of doing problems that way as well. And right, inappropriate comments are going to be deleted. You're going to be timed out, things like that as well. So please try to kind of keep it civil and kind of nice to each other and on topic stuff as well. Okay, so we're going to talk a little bit about some geometry stuff, right? Introduction to some topics or kind of things like that as well. But I have kind of two quick warm-up questions that aren't really geometry questions at their core, but will kind of just introduce us to the kind of some geometric ideas and stuff like that too. So Christy arranged some balls in a pyramid where kind of one ball rests on two balls below, right? So this is kind of just a two-dimensional pyramid here. And so if Christie's pyramid had 6 full rows, how many balls did she have in total? We're going to do kind of more geometry, actual kind of geometry problems. So these warm-up questions are, yeah, just a little bit of, right, of course this has some shapes, circles, some geometric patterns in it, but it's not a true kind of geometry question there. So if we kind of looked at the pattern here, right? So the first row has a single ball in it, right? And then this kind of keeps going up by one each time, right? So this kind of would be, right, the pattern we have there. So we have 4, 5, and 6. And so then adding these all up, we get 1 plus 2 plus 3 plus 4 plus 5 plus 6. And hopefully a lot of you guys know the trick for that as well, right? So this is 21. And right, the very good formula to know there is this is 6 times 7 divided by 2. So anytime you kind of are adding up the numbers 1, 2, 3 up to a number n, you can take that number, multiply by, right, the next number, and then divide by 2. So that's kind of good here as kind of our trick for this question as well. So like I said, just a little bit of warm up here. We have some just, circles arranged in this kind of triangular shape, different things like that. But this isn't really a geometry question either. Second warm up isn't really a geometry question either as well, but this one is a little bit more involved, a little bit more kind of patterns we have to kind of think about here. So now we have Elise using light and dark squares. So we have kind of these like this. And she's forming kind of larger and larger grids, right? Checkerboard shapes, but they're not kind of officially filled in just like a checkerboard, where she keeps adding a light edge, so all of the sides are light, and then the next one she adds every other kind of square dark. Yeah, so if you've seen these problems before, right, I'll say a little bit more again about Zimmel in a second, but yeah, you might have seen this pattern before as well, so that is good. And we want to know how many dark tiles she will need for her 10th square in this case, right? So this pattern's kind of alternating here. We have a first square, a second square, a third square, like that. So kind of first, second, third, fourth, and fifth. And so then kind of we can go from there, continuing on as well. Okay, so where is this answer of kind of 36 coming from? So I think people are kind of recognizing the pattern here. So do you guys see in this square we have 4 kind of dark tiles. The second and the third is still the same, right? So this will also be 4 tiles here, right? So now in the next one, let's be kind of clear a little bit what's happening in this case. So in the next one, we have all of these squares around the outside, right? So in this case here, right, we have 3, 3, 3, 3. So does everybody kind of see for this one, the number of squares on this kind of outside is going to be 3 times 4 is 12 in this case. Now, here is a good question we want to kind of talk about here. So what are we kind of talking about in terms of the question, right? So I'm going to talk about these kind of things a little bit more later on here, right? So how many dark tiles would she need for her 10th square, right? So if we're talking about a square, what is a square, right? This whole shape is, right, we have bigger and bigger squares in this case here, right? So kind of when we have a full square here, in the 4th square, are there 12 dark tiles? I think we know what a square is. What I want to kind of point out here is that aren't there 4 still squares that are dark in the middle here as well, right? So this one is 4 here. So the 4th square in total, right? Let me put this as a caution here, right? Caution, right? The 4th square has a total of not 12, but 16, right? Okay, right? So this kind of is what we have here for this 4th square, right? So I think a lot of you guys are recognizing the pattern here of, right? So we start with 4 dark ones, and then we have 12, right? And then we kind of have, right, no new ones added in the 4th square, right? So we want to keep track of kind of the new tiles added along the way. And we can kind of use that to our advantage for coming up with the answer. So, right, in terms of the new tiles, so we have 4 new tiles, right, then 12 new tiles. What is the next amount of tiles that we're going to be adding, when we add the sixth square, right, does everybody see the next one here is going to be 5 times 4? Right? And then the next one, right, we're only adding every other kind of we're talking about, right? And so then the next one is going to be 7 times 4 is 28. And then lastly, right, we have 9 times 4 is 36. So this is where a lot of these 36s were kind of coming from. Now, what is the sum of all of these? So 4, 12, 20, 28, 36, right? We have here a total sum that is going to be, right, 40 plus another 40 plus 20, which is then 100 here, right? So 100 is the total number of dark tiles we're going to need in that last square, right? Because that's kind of the pattern for how it works here. Right, so each time we're kind of adding a larger and larger amount of new tiles, but that's kind of what we have here as our kind of last one here. Okay. Okay, guys, so remember, let's keep our kind of talking relevant to the problems, please. So yeah, the 36 was this last, right? That's a good question here, but that was the last of our pattern, right? So seeing the pattern is a good first step, but then we kind of need to figure out how do we combine those to get our final answer there. Okay. So, quick intro, right? Solving a geometry problem. As we just kind of saw here, reading the question carefully is important. Right? You want to make sure you're kind of knowing exactly what you want. If we're talking about kind of an area or a perimeter or a side length, right? There's different questions we could kind of ask there. Draw and label a diagram if needed, and kind of what knowledge do you need to kind of figure out the answer to the question as well. Especially for this morning, the elementary school kind of problems, we're not going to need too much geometry kind of knowledge. So very, very kind of basic stuff we're going to kind of need in this case. Okay, so I know almost everybody knows all of these things, but I want to kind of make sure that we are kind of talking about a quick review of things like that as well. So, right, two-dimensional shapes, right? Plane figures. These are things you could draw on a piece of paper, right? Things like that as well. All right. You have perimeter, so distance around the shape, and the area, the amount of space a shape takes up. And so then in terms of this kind of stuff here, this is how we kind of are talking about the common shapes. Rectangles, triangles, circles, we'll see a little bit kind of talking about those kind of things here as well. Right, so let's kind of try to focus, please, and kind of things like that here as well. Okay, yeah, so these are some of the basic formulas, right, for some of these common kind of shapes there as well. Okay, so in terms then of three-dimensional shapes, quick review, right? Surface area is the area kind of all the pieces on the outside. Volume is kind of the 3D space, kind of something it's kind of talked about there. And right, the two common shapes here are the rectangular box. So we have kind of the surface area and the volume of this rectangular box, and a sphere. We're not going to really need a sphere too much here, but that kind of sphere there, right, 3D analog of a circle can be helpful in different contexts. Yeah, so not sure kind of how many decimals we really need for pi, but everybody is kind of doing a good job sharing approximations. Remember, pi is approximately equal to 3.14. That's probably good enough in a lot of cases as well. Okay, so like I said, right, pretty easy problems we're going to be doing today. As you've already noticed, and you will probably see throughout the rest of the problems, right, these are kind of elementary school, so kind of upper elementary, right? This would be typically maybe grades 4 and 5, something like that, 3, 4, 5 maybe. Might be kind of easy problems, kind of things like that. But I would recommend, if you guys want some kind of more practice, right, checking out ziml.airteam.org in the next couple of days, right? We have some kind of free problems there, daily problems, monthly contests, other resources, stuff like that as well. Okay. So now, right, thank you for bearing with me through the little bit of an introduction here. Let's try to kind of start solving some problems here, right? So, right, remember, focus, please, right? Off topic will start being timed out for 5 minutes, I think. Okay. So, our first problem here, right? None of these problems, right? These are elementary school problems, right? Just want to kind of practice things like that here. So, right, we have 4 congruent rectangles in this case, right? And so we know the height of the full kind of rectangle is 8. And then we kind of want to build up the kind of area of the entire large kind of rectangle there. Okay, so, right, there's a couple of ways we could think about this prop, right? So, what would be some kind of ways of thinking about our height or kind of putting stuff together that way, right? So we already have the diagram here, but it's still good to kind of label the information we are given, right? So this kind of distance is 8 when we have this here. We have fairly straightforward problems. I think some of them will be a little bit harder along the way. Now, does anybody have a really nice way of kind of breaking down this prop? So there's a couple of ways to do this. Yeah, it doesn't say the width. That's kind of a good question here. So there's a couple of ways to kind of think about this here. I think the easiest way is, right, can we divide up this diagram in a nice way? So that's kind of my way of thinking about this. A lot of you guys, I think, are doing this in your head, right? But I just want to kind of draw this out as well. Notice here that what happens if I extend the line across here? And actually, let me do this in red as well. Right, if I extend this line across here, I get a couple of squares. And, right, actually I can do the same thing here as well, right? Remember, since all the rectangles are congruent, that means they're all the same, right? So since we have 4 identical rectangles, right, they are congruent, we can divide the diagram into 8 squares, right? So because of this, right, and this is where everybody's saying the 4, right? Where are these 8 divided by 2's coming from? Right? They're exactly saying, okay, we can split this up into a bunch of kind of squares that have side length 4. So, right, then however you want to finish this problem, you can finish the problem in many ways at this point, right? So one way to do this, right, so to come up with the final answer, right, we can do 8 times, what is the width now? 16, right? So 8 times 16 is 128. We could also do 8 times 4 squared, right, is 128 as well, right? So where is this kind of second answer coming from? I'm thinking about it in that case as 8 of these squares that each have an area of 16, right? So once we divide it into 8 squares, we know the area of each of those squares, and then we're kind of good to go from there. So different ways to do it is fine. And yeah, I know a lot of these are pretty straightforward, but that's kind of okay as well. So, next problem. And this one is mainly as a kind of way to help us review a little bit of vocabulary in this case. So here we have this vocabulary of regular pentagon in this scenario. So we have the diagram here. So just as a review, remember regular shapes have all sides and angles the same, right? So here we have kind of a pentagon that has, right, 5 sides. Okay, so this one is probably even easier once you know the vocabulary, right? Once you have the vocabulary here, you should be good. Because we have a length of 8, and a length of 8, and a length of 6, and a length of 6. Well, what do we know then? Regular polygon. So if we have lengths of 6 there, all of the sides are 6. 6, 6, 6, 6. And then we have a bunch of 8s as well. Okay, guys, let's please try to focus here. Okay, so, right, we have a bunch of 8s in this case. Now, one kind of little warning here, especially for easy questions, make sure you're not making mistakes as well, right at the end, right? So what is one common mistake I would think here, right? Remember, we want the perimeter, so only the outside edges, right? So we don't actually have all of these numbers in this case. So let me kind of write it like this. We have 4 times 8, and then plus 4 times 6, plus 4 times 8, plus 4 times 6, right? So we really have here then basically 8 times 8 plus 8 times 6. And if you want to kind of do these calculations, right, 64 plus 48, and then you're going to add this up to get 112 there. Yeah, so, right, just remember here kind of little mistakes at the end can kind of ruin the kind of problem as well. Okay, so that's kind of what's happening if we're kind of talking about this problem here. Okay, so the next problem here is actually very, very easy too. So I want to do it though because it's very good to just remind ourselves of the formulas and how things work here. So here we have a diagram. We have three squares. So just highlighting what's kind of in important along the way here. Right, so we have three squares. Their side lengths are 1, 3, and 5. And these are stacked on top of each other. And we want to kind of remind ourselves of the kind of formula for the area of a triangle. So there's all kinds of tricks for doing these things, right? You could do the total area and subtract off the kind of missing pieces, things like that as well. But, right, so let me just write that down actually. So in certain problems, you might do, right, the three squares minus the regions outside the triangles, right? We'll see a problem like that kind of in a little bit here later today. But in this case, it is easy. So why is it easy here? So what kind of is easy about this one here? Right? What's easy about this is remember our formula for the area of a triangle, right? Remember area of a triangle is 1/2 times base times height. Okay, right? So 1/2 times base times height here. Now, we know the base, right? The base is easy here is 5, right? So this kind of is our 5 there. Now, what about the height, right? We actually can do the height very easy as well, right? Because actually, if we draw a straight line all the way down here, right? Notice that we know all of these distances as well, right? What is the problem here? We have a 5, right? We have a 3, we have a 1, right? So the base is equal to 5. The height is equal to 5 plus 3 plus 1, right? So 5 plus 3 plus 1. We know right away then that height is 9. So we have 1/2 times 5 times 9. And so we're going to get 45 over 2 as a fraction, or 22.5 as a decimal. So let me just kind of double check that kind of as well. And so kind of hopefully people kind of are starting to see kind of the pattern here as well, right? So this is kind of how you just break down a problem or kind of approach it in kind of different ways as well. Yeah, so depending on what types of problems you've done before, right? This might be easy, this might be hard, right? Depending on what age you are, right? Let's all, right? The important thing is we're all going and at our own pace and trying kind of our best, right? So 9 times 5 divided by 2 is how we kind of have this problem at the end. Okay, so the next problem is a good problem to review a little kind of trick and stuff as well. Yeah, and so everybody's own definition of easy is going to change depending on how much math they've done or depending on the different kind of types of problems they have kind of seen before as well. Okay, guys, please let's stay focused here. So our next problem here as well is, right, these four squares are in the kind of diagram drawn like this. So remember, this means we're kind of connecting the squares by their diagonals, right? So that's a good kind of vocabulary word here too. And so we know we have a square here at the bottom. This green square at the bottom has an area of 8. So this square has an area of 8. And we want to find the area of this square at the top here. Now, probably along the way, we might also want to deal with these two two squares in the middle, right? These two blue squares clearly have the same area as well, right? So we kind of really have three types of things to kind of be dealing with in this problem, right? So the green area is 8, and then we can kind of go from there. So green area is 8, blue squares area is question mark, and then orange square. Okay. So yeah, this kind of is the question, how do we kind of relate these things to each other? Now, you can do some Pythagorean theorem. We're actually going to talk more about the Pythagorean theorem in the kind of afternoon lesson as well. But one of the things I always want you to be thinking about, and if you learn kind of one trick from today, I want you to kind of be thinking about breaking up areas into smaller pieces. So let me kind of do it like this, where what if I cut this blue square into 4 pieces like this? Right? And so what's nice about this now is we can actually see a pattern here. So if we cut this up, we cut the square in half, right? And so that means we have 4 and 4. But now we have kind of 4 pieces of that 4, right? So actually the blue area, the blue square, has, whoops, and before I messed this up here, right? No 14, I was thinking about 16, I think, in my mind. All right, so the blue square has area 16, which is, right, double the green square. Okay, so that's kind of what we have there. Now, can this pattern repeat? Well, sure, right? What if I divide this orange square now into 4 pieces? The blue square was 2 pieces of 8, right? So we have 8 and 8. So we kind of have 8, 8, 8, 8 that way as well. Okay. Okay, so here we have kind of then another pattern, right? So let me write this as the orange square, right? Orange square has area, right, 32, which is double the blue square. So this kind of pattern, right, is a good one to know in general, right? So this kind of is a nice pattern to think about. We always have, if a square kind of shares the diagonal of another square, like this, then you can double the area kind of that way as well. So that's kind of a pretty helpful kind of thing to talk about too. So lastly, kind of one kind of extra piece of information I want to kind of talk to you about quick for this problem is a nice formula for area that you might not have seen before. Okay, guys, let's try to focus, please, here. So let me give myself a little extra room on this side here. So kind of an extra fact. So suppose you have a square with a diagonal. So if I give you a square, and you know the diagonal is D, you actually have a nice area formula in this case as well. If a square has diagonal D, its area is D squared divided by 2. So yeah, those of you kind of mentioning, you know, the Pythagorean theorem and stuff like that, that is a good way of doing this as well. And this kind of is kind of a way we could use this in terms of a general formula here too. So try to kind of think about this extra kind of formula, this extra kind of fact as well. That could be kind of helpful in a lot of problems as well. Okay, so I promised you one of these problems where we should be doing kind of some subtraction in this case, right? Or kind of other things where we might want to look at relationships between different parts of the problem. Okay, so here we have 2 quarter circles, and these are drawn to fit perfectly in a rectangle with length 6, as shown in this kind of diagram below. And we want to know the combined area of these kind of shaded regions here as well. So I think a lot of you guys are getting good at this. So, right, what do we call this kind of distance in terms of kind of our kind of circle here, right? This is our kind of radius, right? So this is the radius of our circle, right? Anytime we have kind of things like that there. So what do we know then for the radius? Well, this radius has to be 3 because 2 of the 3's make up our 6, right? So this circle has a radius of 3. So what is the kind of combined 2 quarter circles, right? So if this was a full circle of radius 3, it has area, right, pi times the radius squared, right? So if we have a full circle, we have pi times the 3.1, so 3.14 times 3 squared, right? So this is 9 times pi. Now, we actually don't have a full circle, right? What do we have as a full? We don't have a full circle. We have 2 quarter circles, right? So 2 quarter circles is the same as half of the circle. Right? So the shaded region is not that kind of full shape, right? The shaded region is, right, we now have 1/4 of this thing, right? So, sorry, half of this thing, right? We have 2/4, so that's a half. So 9 times pi divided by 2 in this case here. Okay. So, right, careful here with your question as well. Do we actually need to know the answer for what pi approximately is? No, remember we're just looking for k, right? So this is 4.5 times pi, and so k is 4.5. So this just 4.5 is our answer here, right? We're not dealing with anything else in terms of 3.14 approximately or kind of stuff like that as well. So that's kind of what we have in this case. Yep, pi could be kind of it's a number, right? So we don't kind of really care about what that number exactly is for this problem here. Okay, so let's try to do maybe 2 more questions here. I'm going to jump around a little bit here. I want to first go to my last, whoops. Let me pull up, since I'm jumping around a second here, and make sure we're kind of okay in this scenario. So let me make sure I am back up on the screen as well. Okay, so sorry about that really quickly. So hopefully everything is back to normal here then in a second. So right, this question I want to look at here is kind of Alice building a cube with kind of some different volumes and stuff like that there. So Alice builds a cube with volume 216. Bree builds a cube with surface area 216. And we want to know the surface area of Alice's cube minus the volume of Bree's cube. So, right, we kind of have a kind of chart in a sense here that we're kind of looking at in this case. Okay, guys, let's please try to focus, stop with the zeros. Okay, yeah, so I want to kind of get back on track a little bit for our last few minutes here. So yeah, so Alice builds a cube, right? So remember, for a cube here, let's draw kind of a quick diagram and a quick kind of setup here. So, right, we have our at least roughly drawn cube in this case. And remember that for a cube here, right, we have kind of a volume is involving a s side length cubed, and then kind of going from there as well. Right, so if we have our side length in this case, right, what kind of happens then here? Okay, so we know that the area is equal to, sorry, volume is equal to s times s times s, right? This is our s cubed for the kind of place here. Okay, guys, let's please stop spamming the answer. And so the surface area is 6 times s as well. So, right, what is kind of happening here? So let's focus each person at a time. So Alice has a cube with volume 216. Right? So if the volume, right, is s times s times s equals 216, and so this is what a lot of people were kind of saying, right? How can you get a number times itself 3 times equals to 216? this tells us then that the side length equals 6. Now, here is the weirdness of what's happening then, right? So what is the surface area of Alice's cube, right? The surface area is 6 times 6 times 6 equals 216, right? So, guys, let's please try to kind of focus here, right? We're almost kind of done here. We'll do one more questions quickly here, right? So this, right, is actually a special scenario, right? So actually, for a cube with side length 6, the volume and surface area are both equal to 216. Right? So this is kind of a special cube. It's actually the only cube that kind of this happens for, right? So this kind of is the only one where this is going to kind of work out in this way. But this actually tells us that both people have built the same cube, right? So Bree has the same cube, size cube, as Alice, so the answer is 0, right? So this kind of is what happens in this case. These are kind of exactly the same. It doesn't matter the order that you're kind of doing things in as well. Okay, so let's do one more quick question here. So Francine is building a solid tower of blocks using cubes each with volume 2 cubic centimeters. And this one is kind of a real reading comprehension just to kind of end with as well. Yep, so if you need to get going, that's fine. We're going to do this problem real quick, and then we will kind of say goodbye right here. So, right, we're building this block with cubes of volume 2 cubic centimeters. Each layer uses 20 cubes. And the total volume of this is 200 cubic centimeters. So there's different ways to think about this. You could write kind of a full equation at a time. Guys, please, Ian, I appreciate the help with trying to tell people to focus, but sometimes that is worse than everything else. Right, so every cube has volume 2. So if we just take this piece by piece, so step 1, every cube has volume 2. Each layer has 20 cubes. So the total volume of one layer is 20 times 2 equals 40. So that kind of gives us a now layer here. And so, right, if the total volume is 200 centimeters cubed, there must be 200 divided by 40 equal 5 layers, right? So yeah, this one is a good kind of mixing of word problems and geometry. We're just kind of putting all of the pieces together, and kind of that's what we kind of have for our answer here. So this kind of is a good one to end on, right? Little bit easier, but still kind of seeing the different pieces for something that we can kind of put together to give us our answer there as well. So, want to quickly end here on, right, the reminder that if you want some more problems like this, right, I hope you guys all kind of check out zimmel.airteam.org. Right? I'll be doing a middle school, so slightly kind of harder problems. A little bit later, in a couple hours, about 2 hours from now, kind of doing some kind of middle school problems this afternoon. Okay, yeah, so Caden, okay, so right, as far as kind of how that goes then, right, I hope to see you guys on the Zimmel site, right? Hopefully I'll see some of you guys in the afternoon then as well. So, right, in a little bit, we'll kind of be doing some of those slightly harder questions for some middle school grade levels. This recording will be available a little bit later. Thank you guys all for kind of taking the time to work with me today. And I will kind of see you guys hopefully in the future as well. So, just ending with stay safe, everybody. Wash your hands, right? Stay a safe distance from everybody. So I kind of hope you guys all stay healthy. I hope all your families stay healthy. And kind of in the meantime, hopefully you can still take a little time away from all of your video games you were trying to talk about right now and still do some math problems along the way too. So I'll see you guys all later on. Goodbye.